Good afternoon. This is the part 2 of the video. So the first part was dealing with surds, and now we're dealing with quadratic equation. So, and a quadratic expression is any expression that can be rearranged to have the form of a x to the power of 2 plus bx plus c equates to either 0 or y. So sometimes this part is equates to y. In simple term is that where a is not what equates to 0. We know that if a is not equals to 0, then we have x to the power of 2, and that is y. And this is still the quadratic equation, by the way. So now we have a situation where b and c can be any number, but we know that if b equates to 0, then we have this situation applying. And then if we have c equates to 0, then we have this situation applying, where we can find the value of x using the following fact. Okay, so this is very important. And if you know how to apply principles, it's very easy to come to these conclusions. So how do we get to this answer, which you'll be using there? So if we have ax squared minus c equates to 0, and this only works if c and a are opposite signs. In other words, if we have negative ax squared plus c equates to 0, that can also work. Why? Because if we say plus c divided by a, square root of this part will give you what? Let's say plus c divided by a plus or minus. If you take a square root of a positive answer, it will give you what? Positive. It will give you a value, but if you take a negative square root, you can't get a value because the square root graph does not exist in the part on the negative x-axis. So here we have negative c divided by negative a. The answer will be that x squared. So this will be x. And then this part will cancel out and will become positive because it's negative divided by negative, and that will give you plus or minus x of c over a, which is still the same thing as this part. Now we have an example that gives you, which is basically c over a. A is 1. We can see that there is a 1 there, and it will be square root of 4, which is the c value, which will be 2 divided by 1. Square root of 1 is 1. So we give you answers plus minus 2. And if we look here, where c equates to 0, we know that our first answer is always equates to 0. And then the second answer will be what? Will be b over a. So that will be your x value. Will be minus b over a. So we give it in this form. So these will be your two answers that you have. So note that both of these things do have what? Both do have scenario 1 and scenario 2 will yield 2 answers. So we know that they will always have 2 answers. In some cases they are same, some cases they're different, but in most cases they will be different. Now let's deal with factorizing. But this part deals with constructing an equation for factorization. Or in this case, we do not factorize it, we just construct it. In some cases, I do like to skip this one because you don't use it much. A length of a rectangular field is 40 meters, right? So that's the length is equals to 40 meters. Its width and its area is 600. And the area, the length of a rectangular field is greater than its width, right? The length of a rectangular field is greater than its width. Is 40 centimeter greater than its width. So the length itself is the length of a rectangular field is 40 meter greater than its width. So it's that one plus 40 meters. Okay, and then width will be just basically what? We don't know what width is. And then its area is that one. Form an equation involving the length x and the field of the field. So it will be x equals to w plus 40 meters. So that will be what you're dealing with. Okay, so just gonna go up to the example quickly. Okay, so we have and then we can say the width is actually what? The X there. So let's just do this. Just gonna do this. Meters. So we can construct our rectangle. So this will be X, right? This is X minus 40. Let's just call it that. So we have what? The area, which is X minus 40 times X equates to 6,000. 600 to 6,000. Yes, 6,000 meters squared. This will be X squared minus 40 X, making a mistake, minus 40X minus 600. Okay, now this will be your final equation. This will case to 0. Don't try to do anything with it. They didn't want you to factorize it, so they just rewrite the equation there. Now, let's start with factorizing. That's the first part with factorizing. So if you have an equation like this one, and you're required to factorize it, this is x squared plus 7x plus 12. You're looking for factors of 12, right? When you do what? When you add them, they give you plus 7. Now let's find them. Factors of 12. So that's 12, 1, divided by 2 gives you 6, divided by 3 gives you 4, divided by 4, it goes back. Then it's a loop. So we add them. Remember, this says we should add them. And then we get 13 here, we get 8 here, and we get 7 there. Now we're looking for these vectors. The signs are correct because it's giving us the right sign here. So we just gonna do what? We're gonna write our 2 bracket, and then we have the factors of this x right on the first position. The second position goes the plus 4, and then the plus 3. Doesn't matter which one you put first because it's the same. So you have successfully factorized this part. Okay, then we move on to example 2.8. Example 2.8 is a similar thing, but we're looking for factors of 24. When you minus them, they give you negative 2. We start with 24. We divide by 2 gives us 12. Divided by 3 gives us 6. Is it 6? It's 8. Divided by 4 gives us 6. Okay. Now we're going to do what? We're going to minus those factors. So we're going to start minusing these guys. I usually say flip it, but it's okay. We don't have to flip it this time. We'll flip it if this first part fails. So this gives you 23. This gives you 10. This gives you 5. This gives you 2. Now, note that this is positive answers. What does this mean? It means that we need to just move the sign to the other side. So we can change these ones into positive and we move it there. But the one that passes is the one that actually matters, because this one now doesn't give you positive 2, but it gives you negative 2. Now, what do you do with this? It's negative and this is positive. So we open our bracket. Remember the brackets. And then this is x for this vector. And then we have plus 4, and we have minus 6. That's what we all need to add there. If you multiply these things using FOIL, you can just check if the answer is indeed what you factorized to be true, because it must always give you back exactly what's on the top there. So it will be minus 6x plus 4x, and then this is minus 24. And this exactly gives you negative 2x minus 24 x squared, which is exactly what you had first. Now let's look at this one. This one you still have the same thing, but you're looking for factors of 100 divided by 2 gives you 50 here. And 3 does not go into 100. 4, yes, 25. 5, yes, which is 20. Now, we're going to do what? We're going to add them. So we need to go on 6, 7, 8, and 10, which is 10. Okay? 11, no. 12, no. 13. Let's just leave it because we're going back to that part. So we're going to add them because this part says you must add them. This gives you 101. Just having fun here. This is 152. And this is 29. And this is 25. And this is 20. Guess what? This is what we need. Okay. Now we do what? We open our bracket. We can actually start with them if we want to. The signs are correct. So, the signs are not correct. Why? Because now, how do we obtain a negative answer if we're adding? It means that we need to, there's two ways of adding. There's minus minus. Minus a gives you negative 2a. Plus a gives you 2a. So if we know that fact, we can actually apply it here. You can say this one gives you negative 20. So then both of them will be negative 10, negative 10. And in this case, we actually have the first time we meet this bracket looks exactly like that bracket. We can say it's negative 10 squared. And this is a nice fact actually, because now we know that if we have something like this, if we have x minus or plus a squared, we can actually expand it and say if we have x squared minus 2a x minus, let's say it's plus, what is it, a squared. We know that if we divide this part by 2, we get our a value. If a value squared is actually this part, we know that we're dealing with this form of relationship. How do you determine that? Divide this one by 2, you get 10 times 2. 10 squared is indeed plus 100. So we can actually just factorize it and just say it is exactly like this one. I don't know if that makes sense. Now, this part is an example of differential of two squares. I would suggest you pause the video and try to figure out how to factorize this one. Okay, let me do it. So it's x for differential of two squares, because we are already minusing. And this is an example actually of b equals to 0. And if we go back to the b equals to 0 part, we can actually just say b equals to 0. The answers is what? Plus or minus c over a. So square root of c over a. Let's go back. X equates to plus or minus square root of c over a. And c is 49. And then a is what? It's 1. So that's the square root of that one. So that's plus or minus. Square root of 49 is 7. So that's 7. So the answer is just basically x equals to plus or minus 7. But we want to factorize it. So it's x minus 7. It's x plus 7. This is the answer they are looking for. This is if this only applies if you have x squared minus 49 equals to 0. This is an equation. Then we have to find the values of x as the following values. And if this just say factorize, I just want you to write it in this form, which indeed can give you x equals to 7 and x equals to negative 7 if this was equals to 0 there. But in this case, that's not true. So we just need that part. So they'll give you a mark for this part if you do it like that. Now we meet our first case where a is not equals to 1. When a is not equals to 1, we're dealing with the following. We get the factors of this guy, vector pairs. And I always say that you flip the one with the least amount of factors. So 6 has the least amount of factors. 6 and 1, 2 and 3, 3 and 2. That's about all. 12 is 6 and 2, 12 and 1, 3 and 4. That's a lot. So we just leave it at that. Okay, this one needs to flip the 6 again, so we can just say it's 6 and 1. Okay, now we multiply, now we cross multiply them. So you're gonna do the green part. So that's 2. And then we cross it again, which is what? Because we have to minus it. Minus 36, sorry. This must give us what? 1. So this is not true because this gives us what? Negative 34. Okay, now we try fishing again until we get the right answer. So now you are going to do the same thing here. There's a 6 there. You are going to do the same thing here, but now you just move one step forward. So you see multiplying the first one with the second now. The first one with the second one now. So it's 1 times 1 is 1. And then 6 times 12, you don't even bother. If you minus this 2, it's not going to give you 1. So we can actually just skip that part. And then we have 4 times that one. That's 12. That's not going to give you. So the third row still fails. So it means that this part is not successful. 6 times 2 is 12. 1 times 6 is that one. It's not going to give you 1 when you minus it. So you're looking for the one when you cross multiply them, the product, when you minus the product, it will give you 1. So it seems like most of them are not going to be successful. But let's try now. This row we can cancel out because it's not going to work out as well. Let's try this one. 2 times that one is 4. That's 18, so it's not going to work out. That's 2. Okay, not going to work out. This one is 8. Ooh, that's it. That's it. So this 2 times that 4 is 8 minus 9 equates to negative 1. So now the problem here is that you have signs that are swapped. So remember, this side is a sign side and this one is a variable. So the variable will be x, right? So x is going to be on this bracket. If we have to put x here, it will be here, right? The sign will go somewhere here. So we want to determine which one is negative and which one is positive. Now, this part just tells us that the signs are quite opposite of what they're supposed to be. That's why the answer is opposite of what it's supposed to be, because it's negative here, it's positive there. So we need to fix that. So to fix that, it's quite simple. We basically just swap the signs, but how do we do it here? We say, okay, to multiply this one with that 4 to give us a negative, that 4 must be negative. Therefore, this part must be positive. In other words, we can write now our brackets. So it's 2x plus 3, and then it is 3x minus 4. And that's your final answer, basically. Because then you figure out how these signs correspond with what bracket. So remember, you just take this bracket as it is and this bracket as it is, and you just put them there. You can see, quite frankly. And you can just ignore this part because it's no longer applicable because we found what we were looking for. You can even put it right here. It doesn't matter. But we were not looking. We found what we were looking for. So the one that you're looking for, I'm just going to highlight them here because I fear that they might not quite be visible. If you don't understand this part, just play back the video again and see if anything is clear. Okay, now we're dealing with equations now. So the part that we were dealing with before this was what do you call it? Expressions. Now we're dealing with equations. So if you can factorize this equation, you can basically find an answer. Okay, so can we factorize this one? This is the first one that we had to factorize. Can we see? Let's see that we can factorize it now. So we can have x. Okay, now to get this part to be the difference to be 40, let's say 60 times 100. Can this part give us 6,000? Yes. Is the difference giving us, let's say 100, 60 minus 100? Is it giving us 40? Minus 14? Yes. So all of these things are true. So those are the factors that we're looking for. You see, you can just narrow it down your factors, basically, if you know exactly what you're doing. And now this equates to 0. So we can say x equals to negative 60, or x equates to 100. And those are the two answers that you're expected to find in this scenario. And if it's dealing with length for that method, this we can just say it's not true because you cannot get a negative length. Okay. Now, this is the first time you're dealing with quadratic equation in disguise. So, sorry, whenever you're seeing a sort of a ratio of x to the power of 4, x to the power of 4 is 2, x to the power of 2 can be the same as k to the power of what? 2 is 2k. So it's a ratio of 2 is the exponent in a ratio of 2 is to 1. This means that you're dealing with quadratic equation in disguise. And you can see here that's true. Now you let k be the lowest exponent, which is x to the power of 2. Now you say, okay, x to the power of 2 to the power of 2 minus 13 x to the power of 2 plus 36 equates to 0. Now you say let k be x to the power of 2. So x to the power of 2 equates to k. K squared minus 13k plus 36 equates to 0. Okay, now you have what? You can factorize it. You know that k goes here. Factors of 36, when you add them, they give you 13 is, I do not know. So let's just find out. What are those? So it's 2, 36 divided by 2 is about 13. And then you have to add them to give you 13. So we have to do some more. So that will be, let's say 12. So it's 3, it's 12. So if you add these guys, they give you 15. So not 13. So we're going to keep doing it until we get to the answer. Let me just get my calculator out so that I can just do this thing. So 36 divided by 4, that's 9. Let's see, 9. Okay, that's what we're looking for. So if we add these two, they give us what? 13, but they're not giving us negative 13. So we must remember another way. There's another way of adding, which is negative, negative. So we can say it's negative 9, negative 4 equates to 0. And k equals to, therefore, k equals to 9. K equals to, k minus 9 equals to 0, or k minus 4 equates to 0. And in this scenario, we'll just say k equates to 9 or k equals to 4, because we just take these ones across the border. The sign changes. And then we know that we did say k equals to x squared, so we will bring back our x squared equals to 9, and then our x squared equals to 9. And then x equals to plus or minus square root of 9, and then x equals to plus or minus square root of 4. This is supposed to be 4, not 9. Okay, and then this is x equals to 3, x equals to negative 3, and x equals to 2, or x equals to negative 2. So those are the 4 answers you will receive in this question. Okay, now that's all for this question. Now, if you're dealing with the next one, it looks very weird because it's a quadratic equation with a hyperbolic equation being solved together simultaneously. So if you think of it, a hyperbolic equation, especially that one, would look like this one on the Cartesian plane. Okay, you will know towards the end of chapter 3, you'll have to know all of these equations. But now I know that this one looks like this, and it's been shifted upwards, so it will look like that. Okay, but what we're interested in this red part. Okay, so since it was moved 2 units up, it means that yes, it is still symmetrically intact. So these answers, if this is A, if it's negative A, this will be plus A. So that's what we would expect. So later on, you would get to learn why am I drawing all of this. So let me start solving it. So you have, let's just start here. X squared minus 2 equates to 8 over x squared. Now you want to make sure that this is revealing its true identity, which is a quadratic equation in the sky. So you're going to multiply both sides by what? By the denominator to remove the fraction. Okay? So it's x to the power of what? 4 minus 2x squared minus equates to 8. And now you take this 8 to this side. So it's x to the power of 4 minus 2x squared minus 8 equates to 0. And now you can say, again, you just bring let k equates to x squared. Now k squared minus 2k minus 8 equals to 0. We factorize this. See, now it looks very easier. Okay, now we have what? Factors of 8, when we minus them, they give us 2. It will be 4, and then we have what? 2 here. K. The signs are not going to be the same. The big one will be negative. This is negative, so this is positive. You can do what we was doing before, and then you can still get the same answer. So this one says the signs are not going to be the same since it's negative. So the only way you yield a negative sign is negative times positive. It's equals to negative, and positive times negative equals to negative. And this one says the big one will be negative. Because the reason being, when you add them, when you're adding negative A plus B, if B is greater than A, the answer will be positive. If B is greater than A, negative A plus B will be negative if A is greater than B. So you can put numbers here. You can just put the number, for instance, if you say 5 is greater than 4, then you just replace those B and A with 5 and 4, and you can just swap it and then let B become what now? 4 and A become 5, and then you just test it. You see why this thing is true. And then we have let, okay. Now we can do the following. K plus 2 equates to 0, or k minus 4 equates to 0. And now this is k equals to negative 2 equates to, and then we have k equals to 4. You'll see that this part is not true. Why? Because if you say x squared equals to negative 2, x square root of plus or minus square root of negative 2, we cannot take a negative square root of a negative answer. So this solution, you can actually just forfeit it. You can just ignore it. Dismissed. So now x squared equates to x. And remember when I said these things must always be negative, must always be opposite signs. You can see by now that if you have, especially, it doesn't apply there, but you will see applies to this part. If I say 2 equates to 0. So if these guys are the same signs, it does not give you a solution. That's why. This is 4. If you take this 4 to the other side, let's say you remove this equal sign, so you say squared minus 4 equates to 0. These are opposite signs, so it will work out We already know that. So this is x squared equals to 4, and then it's x plus or minus square root of 4, which is plus or minus 2. Remember I told you that if it's a, the other one will be just negative a. So it's very important to also know your graphs as well. Okay, so that's all for this. Those are the two answers. They didn't ask for the y value because there is no, these are not original equation. They're just teaching you how to factorize. And here you can do these questions. I believe you have the open PDF, so you can try to sort of see how these things can be done. I'll also, you have a PDF, so you can look at the back there. There is answers as well. You'll see that this activity 2B, it has answers at the back. Okay, so now I must stop the video here, and then we'll talk about completing the square.